Hello, Mrs. Savell.
Hi, you must be one of the treehouse detectives. I understand you need to learn about gears.
We sure do. What exactly is a gear?
A gear is one of the oldest simple machines invented. In fact, it's a wheel and an axle, but with teeth.
Teeth? What kind of teeth?
I'll use these Lego gears to show you.
That's cool.
Gears work when the teeth of one gear mesh with the teeth of another. The first gear is called the driver or the primary gear. Notice when I turn it, the next gear or the follower gear rotates in the opposite direction, but at the same rotational speed.
What happens when you put two gears together that aren't the same size?
Let's see. Notice that the follower gear is 2 times larger and has twice as many teeth as the driving gear. Give it a try.
The follower only rotates half as much as the driver.
That's right, it has half the rotational speed of the driver. Changing rotational speed is one of the reasons we use gears. Another reason is to multiply the force on the axle of the follower gear.
We definitely need more force, but how do you use gears to multiply force?
It's simple. If you double the size of the follower gear, the force on the axle is twice what it used to be.
Is it always that easy?
You can actually calculate the increase in force by simply dividing the number of teeth on the follower with the number of teeth on the driver.
So in this case, the follower has 40 teeth, and the driver has 24. 40 divided by 24 is about 1.7. That means that the force is multiplied about 2 times.
That's right. You're really good with numbers.
What if there are 3 gears?
Let's try it. Here we have a driver with 8 teeth, a follower with 24 teeth, and another follower with 40 teeth.
It looks like the driver gear goes around 5 times for every 1 time that the largest follower gear goes around.
Good observation. To find the force multiplier, you divide the 40 teeth of the follower by the 8 teeth of the driver.
That would be 5. But what about the middle gear?
The middle gear doesn't make a difference except for the fact that it changes the direction of rotation. Let's verify our results to see if the force is really multiplied by 5. I'll place 5 bricks on this lever arm and place 1 brick the same distance out on the lever arm on the driver gear. It balances, so we were correct.
We've multiplied the force by 5, but the follower doesn't move very much at all. It's just like a pulley system. Whenever you multiply the force, you have to pull in a lot of rope to move the load a short distance.
Right. Whenever you use simple machines, there's always a trade-off.
Dr. D said the same thing. He also said that you could combine simple machines in order to get a greater multiplication of force.
Check out this bicycle, for example. The crank works as a lever. We have a gear system. In this gear system, the teeth don't mesh together directly. They are connected by a chain.
A bicycle uses a lot of simple machines.
When you have more than one simple machine working together, like on the bicycle, it's called a compound machine. Here's another example. This crane is a combination of a crank or lever attached to a gear connected to pulleys.
This is really cool. I'll bet that this helps us solve our problem. Thanks a lot, Miss Salvell.
You're welcome.